We have Nitesh coming all the way from Silchar, Assam. So round of applause for him to coming all the way to Goa for us. Yeah, and yeah, please come on stage. Can we have a round of applause for Nitesh? So he's a founding engineer at GreatFrontEnd. So over to you, Nitesh.
Yeah. Hey, hello everyone. I'm Nitesh and I'm a founding engineer at GreatFrontEnd. I hope you all are having a great time at Goa. Yeah, I think before moving forward with the talk, I have a quick question for you all, right? So hands, like how many of you have ever worked with, like, or ever work on internationalizing your React application? Well, I see some hands. I bet like most of you would describe like as not your favorite part of your development, right? So I think either you're working with a JSON file or a Markdown file. Translation is one such task which you always hope that someone else will handle. You know the drill, right? Extract the strings manually, send them to a translator, or like wait for a few days or even a week for translation to happen, and then you check for any formatting issues, and then you repeat this same thing when something changes in your content. So today I'm here to talk about how we transform this process at GreatFrontEnd using AI. So we will also explore why traditional translation workflows are broken and how we discovered AI-powered solution. Yeah. So let me give you a sense of what we are dealing with at GreatFrontEnd. For those who are not familiar with GreatFrontEnd, GreatFrontEnd is a platform for front-end engineers to practice front-end coding challenges. So it contains like JS-based questions, UI-based questions, which users can practice directly in the platform without having to install anything. It contains system design questions as well, which is catered for front-end engineers, and it also has like quiz-based questions, which is especially catered for front-end engineers. So behind all this, we have more than 500 React components which contain UI strings, and then we have more than 3,500 UI strings. Then we have more than 1,000 Markdown files, which powers our questions, questions in our platform, and it also like powers most of our blog posts and most of the content in our app, right? So it's mostly Markdown files, and we support like 3 languages, which include English, Chinese, and Portuguese. So what is the exact problem that we were facing at GreatFrontEnd, right? So the first problem is our app was not 100% internationalizable. We discovered that there were like a few hard-coded strings scattered around the app, so we needed to solve this problem first. So for a hard-coded string to be internationalizable, you need to wrap those strings in a I18 formatter. So either it has to be wrapped in a formatted message component, or it has to be wrapped in a intl.formatMessage function. So at GreatFrontEnd, we use format.js, which is an I18 library. So these two components, like formatted message and intl.formatMessage, is a part of that format.js I18 library. So you might think, right, we can just replace this hard-coded string using this particular component. But the problem is like we have more than 3,500 strings that is scattered across the app. So we cannot just replace like manually going through each and every file. So to solve this, we wrote a code mode to automate converting all these hard-coded string. So code modes are a script that runs through your code base and transform your codes into a abstract syntax tree, which you can manipulate that tree directly. It allows you to like make large number of changes like programmatically in a more reliable way instead of doing like a naive string replacement directly. So this is what like converted, like if you see the first string, hard-coded string, it gets converted into like either of this particular, using this particular component or either of that particular component when you run the code mode. So we use code mode to traverse through every single component in our application and just convert all those hard-coded string and wrap it with this particular 2 component. So we solve this like in with just one command running it, and in just a matter of seconds, So you didn't have to go through every single file and modify those things. So we solved that particular problem. But we didn't solve the harder problem. The harder problem is actually translation. So initially, we were using Crowdin to translate our application. But this is what a translation workflow looks like using Crowdin, right? So you connect the GitHub repo to their platform, to the Crowdin platform, and then you specify the source file. Then you upload those untranslated string to the Crowdin platform. And then you wait for the human translation or machine translation to happen on the translation on their platform. Then you review or approve that particular translation that happened on their platform. And then you pull back the translated string back into your repo. But there were a few issues that we were facing with Crowdin. So the first problem was, it involves multiple steps. You have to upload. You have to wait for a translation. Then you have to review and approve. Then you have to pull back those translated string into your repo. And the next problem is it's expensive. It charges you based on the number of string that you stored over time, and not per the translation run. The cost will explode over time. The next problem is the Markdown support. So our app is mostly a Markdown content. So this was one of the main reasons why we wanted to develop our own solution. So if Crowdin struggles with when a Markdown contains a complex component code blocks and React component inside it. So when you do the translation for such MDX files, sometimes the Markdown's translation breaks. Now, out of curiosity, one day we tried copied few strings into ChatGPT and asked for its translation. And the result were obviously it was surprisingly very good. So that's when it hit us, right? What if we could automate all of this? So this vision became Langnostic, a fast, scalable AI-powered translation tool for modern application. Now, how do you use Langnostic in your application, right? So Langnostic works on mainly two commands. First is Langnostic inits. So these commands, when you run this command, it creates a default Langnostic configuration, which contain all the configuration that Langnostic needs to run. And the next command is the Langnostic translate, which is as the name suggests, right? When you run this command, it translates your application based on the Langnostic configuration that you have set up. Now we have two more flags that you can add on the Langnostic translate command. The first is the debug flag. So when you add this particular flag, it logs all your translation instructions that you pass to the AI and all the context that you pass to the AI, and even the responses that you get from the translation requests. It logs everything in a file. And if there is any error during the translation, it also logs that particular errors in a file. Now the next flag is dry run. So when you run the translation using dry run, it doesn't actually trigger the translation. It prints all the the content that needs to be translated in your console. So the next important thing for a translation to run is actually the config file, the Langnostic config file. So like we discussed earlier in the previous slide, when you run the Langnostic init command, it creates a default Langnostic configuration file. So the config that you see on the screen is config file. This is not a default config file that Langnostic init generates, but this is what a Langnostic configuration will look like for an application. So the first important thing that we need to note here is the model that we pass here. So you can pass any AI model that you want to use for a translation in a Langnostic. The second important thing is the config. So you define what is the source local and what is your target local. And then the next is the concurrency limit. So this defines how many max number of translation jobs you want to run parallelly. And the next is the groups. So groups is basically collections of files that shares a same processing rules or either or a same file type, right? So if you see the first group, it's a collection of JSON file, right? So it's a same type, right? Same JSON file. So you need to pass a few things, right, in this particular group. The first is obviously name for that particular group, and then the next is the plugin. Plugin is basically to handle that particular specific file format. So for JSON file, you are passing a JSON plugin to handle that specific file format. And then string per request. String per request is basically how many number of string you want to pass to the AI translation request. So that many string, it handles per translation. And then you obviously define what is the part for what is the source and the target part for that particular file. And the next group is the MDX file. So you define what's the source and target for that MDX file, and then you define a corresponding plugin to handle that particular specific file type. So for Markdown file, we are passing a Markdown plugin to handle that particular file format. Now let's look into the future, right? What are the features that it has? Now the first is agnostic. It's extremely agnostic. It operates on any text-based files. It doesn't care like what is the file format that you have. So for this particular reason, we build the plugin system so you can work with any file format. We currently support only the JSON plugin for JSON files and Markdown plugin for Markdown files. But user can always build their own custom plugins if they want to use for any specific file format. And next is, it doesn't assume any tech stack, right? It works with any I18 library or any JS framework or any framework, front-end framework. It even works with a Ruby on Rails or even a Django app. All it needs is a Node.js to run Langnostic. And the next feature is you can bring your own AI model, right? Like we saw in the previous slide, you can define what AI model you want to use for the translation. And the third feature is flexibility, right? Since translation works with only a single command that we saw in the previous slide again, you can fit the translation into any of the development workflow. Either you put that in a post PR or in a pre-commit hook or watch mode. So you can work with any development workflow. And also it works with any directory structure. You can define any directory structure in the group. Now, the next is it's efficient, right? It only translates what changed. This is crucial for an MDX file because MDX file is very different from a JSON file, right? With a JSON file, it's very easier to track what changed. But with an MDX file, when one word changed, it's very hard to track what changed, right? So this is very crucial for MDX or a Markdown file. The next is the change resilient. So when you move a translated file around, it's not like retranslate the content once again that we have already translated when you change the file around or when you move the translated file around. And lastly is it's resumable, right? When you stop a translation in the midway, when it is already translating, it should not lose the translation that has already happened, right? So you can just resume the translation where it left. Let's look into the architecture that powers Langnostic and make it powerful and yet simple to use. It works on two main systems, runners and a plugin. So you can think runner as like a brain of the operation. Like it's a main orchestration engine that loads your Langnostic config file, then it communicates with the plugin, and then like it handles and manages all your AI translation like workflow. And next is the plugin. So you can think plugin as a specialist, like it handles all the file-specific format operations. So like in the architecture that you see here, there is not only one plugin that is involved here. There can be multiple plugins that can come into play, right? So here, if you see, we have a JSON plugin which handles your JSON file, and then you have a Markdown plugin to handle your Markdown file. Now, if a user creates a custom plugin to handle their own specific file format, so there can be another custom plugin that can come into here, right? And then all of those plugins will be communicating with the runner. Now, runner does this like some of the core things. So first of all, it loads the Langnostic configuration, and set up the groove in the config for translation. Then it discovers all the file paths and resolves the file path into actual files, and then initialize into the plugin. Once you do that, it creates a job. It creates a translation job queue and manages all the AI, all the concurrent AI translation requests. Once it does all the translation, and once all the jobs are completed, it reports all the results back. Now let's look into the plugin, right? So plugin does three main things. It handles the file-specific, reading and parsing of the file in their specific file format. And once it does that, the main important thing is a change detection. It determines what strings or what contents need to be translated. And once the runners translate those particular content, when it sends it back to the plugin responsibility is to write those translated content back into the target file. If a user wants to build their own custom plugin, right? So this is what a plugin API looks like. The first is the type, right? So it's just a unique plugin identifier. The next is string per request, which we have already seen before, right? You define how many number of strings you want to pass per AI translation request. The next function is the track file. So when you initialize a plugin, this is the first function that calls, right? So this defines which functions or which files you want to register when you initialize a plugin, or these plugins need to manage. So you register those files using this particular function. Next is the get instruction. These functions define a plugin-specific AI from instruction. So you can define a custom instruction for this plugin specifically. This is optional, by the way. Yeah. So the next is get translation string. This function is responsible for extracting what strings or what contents need to be translated. And lastly is the on translation batch complete. When a runner completes the translations and send them back to the runner, send them back to the plugin, this is the functions that handles, or this is the function which decides what you need to do with the translated content. Let's look into the main or the important details that goes behind each of these plugins that we have, we officially supported Langnostic. So the first is a JSON plugin. Before we move ahead, right? So at GreatFrontEnd, we prefer format.js over other JSON format. So format.js is like we discussed earlier, it's a I18 library which provides you a I18 formatter to wrap your hard-coded string. So this is what a JSON format looks like when it get extracted, when the hard-coded string get extracted into a JSON file. So why do we prefer this format over other JSON format? So the first thing is the context. If you see, there are description associated with each of the string, right? So when you pass this string, it provides a context to the AI for translation. But why do we need a context for translation, right? It can have a different translation for the same word without a context. For example, let's say closing a dialogues or closing an account, right? It can have a different translation if you don't pass the context. Next is the ICU message format. It supports multiple ICU message format like pluralization, variable substitution, and even number formatting and many more. And the third is inline authoring. In other JSON file, what you can see is that you write the strings and you define the key in the JSON first, and then you use that particular key in your React component. But with format.js, what you do is you write the string directly in your React component, and then format.js extract those strings automatically into a JSON file. So you don't have to jump between the React component and the JSON file while you are working, right? And last is hash-based string deduplication. So let's say you have a two string, right, which are exactly similar, and you have a description as well, which is exactly similar. So what format.js will do is it will combine both of those strings under a single key and put it in your JSON file. So there is no duplication of the same string. So how does change detection actually work? So in a JSON file, it's pretty simple. It's on a key-based diffing. So you have only two possible cases in a JSON, which is, like, let's say you have added a new string in your JSON file. So the one that you see on the left side is the source JSON file. So you see there is a new string in it, and the JSON file that you see on the right side is the target file. You see that there is a missing string in that particular JSON file. So it's obvious that that particular strings need to be translated from the source JSON file. So after the translation, you add that particular string into the target file. Now there is another case is where you remove a string from your source file. So once you compare, you can see that there is a extra string in the target file, but there is this particular string that is missing in your source file. So when you run the Langnostic translate command, it doesn't actually trigger a translation, but it will clean up your target file. It will remove those string which is not required by the app. The next plugin is the Markdown plugin. It is not as, the change detection in Markdown is not as straightforward as a JSON file, mainly because there are a few problems with Markdown, which is there are no natural key, like in a JSON file where you have key associated with each string, so it is easier to track what has been removed, what has been changed. But in a Markdown file, it is like one big file, right? There is no different block of content or different string. Yeah. So the next is structural ambiguity. When a content change in a Markdown file, it's same. Like it is not clear that if the content has been removed or if the content has been reordered, deleted, updated. So you are not clear what exactly changed, right? And lastly is the order matter. So when you add a new key in a JSON file, like it doesn't matter, right, where you add the key. It doesn't affect the meaning. But in case of a Markdown, you cannot add, when a new content get added to a Markdown file, you cannot add that particular content anywhere in the Markdown file. The content structures and the flow needs to be intact. So what exactly is the solution? We reduce the Markdown file into a key value pair. So now it again becomes a JSON problem. How do we do that? The first step is into breaking down the MDX file into multiple blocks of content. So we pass the Markdown file into a AST parser, then extract the top level block like header, paragraph, list. The parser will parse the MDX file and converts it into a tree-like structure, which is like abstract syntax tree. Now now from this tree you can extract out the top level block like the header, paragraph, and list. Once you do that, you generate a hash for each of this particular content. Now you have a key and you have a content for a Markdown file, right? Now you broke the MDX file into multiple blocks of content. Now you have the key associated with each of the content as well. Langnostic then translate each of this content block into a target language and then write them back into the target files. Now the next part is how do you handle change detection, right? Now that's where the registry files comes to the rescue. Now registry file, like when you run the Langnostic translate command in an MDX file, it creates a registry file for each of the MDX file that you have, right? So what exactly is a registry file? Registry file stores the translation status for both your source and your target file. Now, important thing to note here is that the hashes for the source and the target hashes are exactly same. Now, why is that so, right? It is mainly because when you want to rebuild your target file after a translation or after a content has been updated, you want to map your source content or source block with the corresponding target block. So these hashes allow you to do the one-to-one mapping with the source and the target content block. Now let's look into a few of the operations that involves in a Markdown file. So let's look into firstly when a content or a new block has been added into the Markdown file. So this is a state where language or where a source file is completely translated into a target language. So you have the registry file, you have the target file, and you have the source file. So everything is like sync till now. Now let's add a new block into the source file. So when you add this, when you run the Langnostic command, it creates the hashes for all the block in your source file. Now Langnostic compares the block hashes and the hash that is present in the registry file. Now using a simple diffing algorithm, it identifies that the block JKL is present in the source file, but it's not present in the registry file. So that means this particular block has been newly added into the source file. Now after the translation, when you do the translation, it adds that particular block into the target file, and then once you update a target file, it then updates your registry with that particular block, which is the JKL. Now let's look into the another case where the block is removed. So let's say you have this particular paragraph get started. So you want to remove this particular paragraph from the source file. Now, similarly, when you run the Langnostic translate command, it again computes the same thing. It computes the hash for the block in the source file, and it then again compares with the registry file. Then it identifies that there is a extra hash that is present, which is DEF in the registry file, but it's missing in the source file. That means that the registry and the target file needs to do cleanup. So when you run the command, it cleans up both the target files and the registry file. Now, Markdown file can also be like, the block can be modified or can be reordered. Now, modifying a block is similar to like removing a block and adding a new block into the Markdown file. And reordering a block is similar to like removing a block from their original position and then changing it and moving into a different position in the same MDX file. So it doesn't involve a new hash, or you don't add a new hash into the source or a target file. So it doesn't trigger retranslation of that same content, but it just changes that particular block into a different position. Now let's have a quick demo and see how this actually works in the code. So this is let me just show you what app. So this is just a outdated portfolio app that I have, or a personal website that I have. So this has been already translated into Hindi before a talk. Now we will modifying like few content in the MDX file and see how it works, right? So this is a Langnostic config that you see here. The first thing is obviously I define my own model here. Then you have the groups. The first is the app string. So it is a JSON file. You define the source and the target part for that particular group of file. And then you have the block content, which is the Markdown file. So you define the part, like the source and the target part for that. And then you define what is the target local and what is the source local. Now let's add a new block into this particular file, right? So let's say I add a paragraph or a heading in here. Let's say, welcome everyone. And let's just try to translate this particular content, right? So let's say I run the command Langnostic translate. So it will trigger the translation. So it is triggering the translation. Now if you see, right, this particular, it has this particular, the file that we talk about, registry file, this is what it looks like, right? So you have the hashes for the source and the target file. Now, after the translation, if you see the hash, the registry is updated with a new hash, and your target file is updated with the new translated content. Now let's check into how it does the removal. So let's say I remove the new paragraph that I just added from this particular source file, and let's trigger the same command, right? So it won't trigger a translation, but it will remove that same thing from your target file. So yeah, I think with this, I think we came to the end of our talk. Thank you, everyone, for sticking till the end of my talk. Yeah, for those who are interested to learn more about Langnostic or try Langnostic, you can just visit this website, which is langnostic.com. It is still a work in progress. You might see few contents like in to-do state, but like, yeah, we are still working on this. But yeah, those who are interested, you can go this website and check it out. Yeah, thank you, everyone.
React India.